All right, today we are going to solve radical equation. So basically, an equation that contains at least one radical term with a variable in the radicand is called a radical equation. So for example there, we've got the square root of 2x minus 3. So you see how you've got an x underneath the radical symbol there? And it's equal to 5, so you've got an equal sign in there as well. So that's considered a radical equation. So since a radical is a square root, we can solve this equation by squaring both sides of the equation and then solving for x. So that's what we're going to end up doing. So you can see the solution there of square root of 2x minus 3 is equal to 5. The square root is all by itself on the left-hand side. So because it is, we can square both sides. So the squaring and the square root there cancel each other out. So on the left-hand side, you're left with 2x minus 3. And on the right-hand side, you have 25. And then you can just solve this normally, so you can add 3 and then divide by 2, and you get x equals 14. And then you can always check. You can substitute it back in there for x and make sure that it does equal 5. And so that's what you're seeing on the right-hand side over there is a check of them substituting 14 in there, and they end up seeing, yeah, the square root of 25 does equal 5, so it does work. So steps to solving a radical equation there. You want to get the radical all by itself, and then once it is, you can square both sides of the equation, and then you just solve for x, and then you check the possible solutions in the original equation. All right, so let's look at solving this radical equation here. You've got your steps over there on the right-hand side, so you can read through those to kind of remind yourself what to do. But basically, is the radical all by itself on the left-hand side? Yes, it is. All you have over there is the square root of 1 plus x. So because we do, we can just go ahead and square both sides of the equation. When I do that, on the left-hand side, the squaring and the square root cancel out. And on the right-hand side, 3 squared, there's 9. So now all we have to do is solve for x, so get x by itself. So now we have to get rid of that 1 over there. It's connected by addition, so let's subtract 1 from both sides. And we end up getting x equals 8. And then we can check our answer as well. So I can plug it back into the original equation here. So it's the square root of 1 plus 8. And we're trying to see if that does equal 3 over there. So 1 plus 8 there is 9. Is the square root of 9 3? Yes. So 3 does equal 3, so it does check. So 8 is definitely our solution there. All right, solve the radical equation. So we're supposed to get the radical all by itself. So whatever is underneath the square root, that whole square root thing needs to be by itself. It's not. There's a 2 connected on the outside. We need to move that 2 out of there. So the 2 is connected to the radical there by multiplication. So to get rid of the 2 there, I'm going to have to divide both sides by 2. So on the left-hand side, I just end up there with the square root of b. On the right-hand side, I get 4. Now that the radical is by itself on the left-hand side, we can get rid of that square root. So now we're on step 2. Square both sides of the equation. So doing so, the squaring and the square root there are going to cancel each other out. We're just left with b. And on the right-hand side there we have 16. And then we can check our answer there in the original problem there. So the square root of 16 there is 4. Is 2 times 4 there 8? Yes, it is. So it does check there, so b is equal to 16. All right, it says solve this radical equation here. So we have 1 plus the square root of x is equal to 3. We have to get the radical, the square root there all by itself. So the square root of x has to be all by itself. There is a 1 connected to it, so we need to eliminate that. So to get rid of that on that side, It's connected there by addition, so let's subtract 1. So on the left-hand side, we get the square root of x, and on the right-hand side there we get 2. Now we're on step 2. It says to square both sides of the equation. Make sure you do both sides. The square and the square root cancel each other out. And we're left with x equals 4. Let's check to make sure it does work. The square root of 4 there is 2. Is 1 plus 2 there 3? Yes, it is. So it does check, so our solution of x equals 4 is correct. Let's try another one here. Solve the radical equation. So isolate the radicals first. That square root of 2x minus 1 is not by itself. There is an 8 connected to it. So let's get rid of that 8 over there. So to do so, we're going to have to subtract 8. So now on the left-hand side, I get the square root of 2x minus 1. On the right-hand side, I get 7. Second step, square both sides of the equation. So let's get rid of that square root by squaring both sides. So a square and the square root cancel each other out, and we're left with 2x minus 1. Right-hand side, we have 49. Have to solve for x, that's step 3. So let's just add 1, and then we're going to divide by 2. Right, only thing left to do now is a check to make sure it works. So substitute 25 back in the original problem there. So 2 times 25, there is 50, minus 1 is 49. The square root of 49 is 7. So we end up getting 15 equals 15. So x equals 25 does work. So that is our solution. We have another one here. So this one here, again, isolate the radical. So notice we have to get rid of that 3 out there in front. So to get rid of that 3 out there in front, we're going to have to, right now it's a positive 3. To get rid of that, we're going to have to subtract 3. If you thought that we were supposed to add 3, well, 3 plus 3, there's 6. That will not get rid of it. We have to subtract 3. So then on the left-hand side there, we're left with a negative. Right? The radical is still not by itself. There's a negative out in front of it. So we need to get rid of that negative. So either you have to multiply both sides by a negative, or you have to divide both sides by a negative, or negative 1. So then on the left-hand side there, the negatives cancel out. The right-hand side, we just get 3. So now we have to get rid of the square root there. So we're on step 2 now. We have to square both sides. Now we're on step 3, solve for x. So we're going to subtract 5 and divide by 2. All right, so we're thinking 2 will work. So let's plug it back in the original problem. So 2 times 2 is 4, plus 5 is 9. Squared, well, I'll just write that down, 9. The square root of 9 there is 3. Is 3 minus 3 there 0? Yes, it is. So that does work. So x equals 2 will work in our equation. All right, I've got a couple of them for you to try out right now and see if you can do those. So if you want to pause the video and then come back, and then I'll go through them. All right, so we have to get the radical all by itself. We have to isolate it, so let's get rid of that 4. And now step 2, square both sides of the equation. And then step 4 there, check possible solutions of the original equation. Square root of 9 is 3. Is 4 times 3 there 12? Yes, it is. So our solution there is y equals 9. Letter B, if you look at that one, the radical is already isolated, so we can just go to step 2 there and square both sides of the equation. So square and the square root cancel each other out. So on the left-hand side there we have 5 plus a, and on the right-hand side there's 7 squared, there is 49. Now let's go ahead and get a all by itself. So we're on step 3. It says solve for x, but in this case we're solving for a. So subtract 5. So 44 is what we're getting, so plug it back in and check. So 44 plus 5, there is 49. Square root of 49 is 7. So 7 does equal 7. So a is equal to 44. I can solve radical equations. That was our learning target.